recording. So this is the first meeting of week 15, and we are going directly into our massive review. So what you're going to want to do today is, assuming, I don't know how you, take notes and whatnot. I'm going to go from page 1, and I'm going to start saying all the things that are important, all the things that you need to know, all the things that you might be tested on, all the things that we went over. And you should just make a list of these things. And these are the things that are kind of like, these are the things that I need to know for this class, for this test. So are we ready to begin?
Buster?
Yeah, I have not, if I have not put your grade up online, your test is not graded.
Are you going to be taking roll?
I said I'll take attendance later. I want to get this started right away. I thought I just said that. Did I just say that? I thought I just said that. I was pretty sure I said that. If I didn't say that, I meant to say it. All right, because I want to get the attendance done ASAP. I'll take roll later. Should have done that the whole semester anyway, because I get the feeling people leave right after they take attendance and then they just aren't here the rest of the time. So this way it can be randomly at any random time. I probably should have done that the whole time, but I didn't. All right, so page 13, chapter 1. The first topic we got here is the difference between an individual and a variable. Now this is back 15 weeks ago, 14 weeks ago. What is an individual and what is a variable? Anyone remember? I can't.
Slate.
Good talk. Okay, so can we be more specific than just like? No, nobody?
Sorry, that was my niece.
Oh, hello, niece. What's niece's name?
Brittany.
Brittany, how you doing?
She left.
Okay. Like some people leave after attendance. So what else is new?
But I am late though. I don't know if you started attendance yet.
No, I have not. So the first thing we're doing is the difference between individuals and variables. You should know what an individual is, and you should know what a variable is. These are on page 4. I'll even give you the page numbers so you know where to look. These are both on page 14. And then variables come in 2 different types. There are categorical variables and there are quantitative variables. Yes, we are reviewing. Today is the beginning of our massive 3-day review. Okay, we are again starting from the beginning, chapter 1, page 14. So individuals and variables. Variables come in 2 types, categorical variables and quantitative variables. So you should know the difference between an individual and a variable, and you should understand the different types of variables. In this case, a categorical variable versus a quantitative variable. That's all on page 14. On page 17. The next thing you need to know, on page 17, we talk about the distribution of a variable. In particular, the distribution of a categorical variable. Okay, so again, on page 17, we talk about the distribution of a variable, in particular, the distribution of a categorical variable. We also mentioned the idea of round off error, also on page 17. Round off error being, if you list all the probabilities for all your different outcomes, they don't always add to 100% because you've rounded them. And because you've rounded them, they might add to numbers that are close, like 99.8% or 100.2%, all because of error, round off error. Still on page 17, we talk about one of our first of our 2 different ways of visualizing a categorical variable. Can anyone recall one of the 2 ways of visualizing a categorical variable? A histogram is not for categorical variables. A histogram is for quantitative variables. So, and got that one wrong. So yes, a bar graph, that's actually on page 18, is a bar graph. And on page 17 is the other type of way of a pie chart. Yes. So at 17, we have a pie chart as a way of describing a categorical variable. And on page 18, we have a bar graph as a way of describing a categorical variable. On page 20, can you slow down a little? Sure. How slow would you like me to go?
Sorry, I'm just trying to type down everything.
No problem. Are you a fast typist?
I just came in a little late, so I'm trying to catch up to
I
everything.
see.
Thank you.
Well, it's also being recorded, so you can always watch it later.
Okay, thank you.
But just throwing that option out. On page 21, we talk about categorical variables. In particular, we have one of the two ways of describing a categorical variable. What is the way of describing a categorical variable? What is the first of our two ways of describing a categorical variable? This is on page 21. What is it going to be? These are, did I say categorical? I didn't mean quantitative. I'm sorry. These are quantitative variables. These are the ways of describing quantitative variables. So what's the first way of describing a quantitative variable? Anyone know? No, a way of visualizing a quantitative variable. We have for categorical, we have pie charts and we have bar graphs, a histogram. So a histogram is the first way of visualizing a quantitative variable. That's on page 21. And then the other one comes later. So are you all with me so far in terms of the
Yes.
list of things you need to know? Are we all together? Quantitative is measured on a numeric scale, but it's more than just a numeric scale. You have to be able to do math with the numbers. So it's got to be like adding them and averaging them. These things have to make mathematical sense, right? If we do just something like zip codes, they're numerical, but you can't in a meaningful way add an average zip code, so it's not quantitative. Does that make sense? Yes, we did the STEM thingy, but I'm just going on page order here, so we have not yet gotten to the STEM thinking. So right now on page 21, what we have so far is the first way of visualizing a quantitative variable, which is via a histogram. Now on page 25, we talk about some of the things that we look for in a histogram. What are the things that we look for in a histogram? Well, let's take a look. We look for its shape. We look for its center. We look for its spread. And does anyone recall the fourth thing that we look for in a histogram?
An outlier.
And we look for outliers. Okay, so shape, center, spread, and outliers. Now, when it comes to shape, what are the basic three shape? Can you repeat what a round off error is when you, well, this is more a list of the things that you have to know. I'm not really explaining everything, but round off error is when you list all your probabilities, but they don't add to 100% because you've rounded all of them. And because you've rounded all of them, they're going to be off a little bit. Okay. That's what round off error is. But anywho, so when it comes to shape on page 25, what are the three basic shapes that we right skewed, left skewed, and
Symmetric.
And symmetric, right? Right skewed, left skewed, and symmetric. Okay. So those are on page 25. On page 29, we have our next way of visualizing a quantitative variable. And this way of visualizing a quantitative variable is, somebody mentioned it just a few minutes ago. What's the other way of visualizing a quantitative variable?
Stem plot.
A stem plot. Very good, a stem plot. And on the stem plot, you have your stems and you have your leaves, right? Now, Usually every stem is going to have multiple leaves, of course. Doesn't have to. Some of the stems might have no leaves. But you should certainly know how to make a stem and leaf plot and also how to interpret a stem and leaf plot. And then we had one other type of visual display in chapter 1. This is on page 32. And this one on page 32 is called, anyone recall what the last type of visual display? It's not really for categorical or quantitative. It was kind of like its own category. Anyone remember what it was? A time plot. Very good, a time plot. So on page 32, you should know what a time plot is. And when you're looking at a time plot, what are the types of things that you're looking for in a time plot? What are the types of things that you're looking for in a time plot? We know that in a histogram, you're looking for shape, center, spread, and outliers. What are the things you're looking for in a time plot? This is on page 33. You are looking for cycles. You are looking for trends. Okay, you're looking for cycles. Are things oscillating in a predictable manner? Or are there trends, overall trends? Even as things fluctuate, is there an overall trend in some direction? That is it for chapter 1. How do you think you would do on a chapter 1 test if you were given that now?
Can you repeat the individual versus variable, and what do you mean by distribution of variable?
Sure. First of all, the distribution of a variable is a listing of all possible values that the variable can take together with how likely those outcomes are. So if I have, for example, eye color, something simple like eye color, okay, the ones would be like blue, brown, hazel, pink, whatever various eye colors people have. And then you'd have the probabilities of those eye colors, 2 columns or 2 rows, either way you want to do it, would be the distribution of the categorical or quantitative variable, the possible outcomes and their likelihoods. That is what the distribution of a variable is. Does that make sense?
Yes.
Yes. Yeah. Okay. The difference between an individual and a variable, an individual are the things that you're measuring. Like for example, if I'm interested in the average height and weight and eye color and hair color and waist size and this and that of every American, the Americans are my individuals. They are the ones that I'm actively studying. And the various aspects of them, like their hair color and eye color and this and that, those will be the variables, the things that vary from person to person. Does that make sense? Yes, no, maybe so? Okay, so that's it for chapter 1. Okay, so now let's move on now to chapter 2. Our goal is to essentially cover the first tests material today. That's the hope. So in chapter 2, we are now turning to page 46. And on page 46, we have our first measure of center. And this measure of center is the mean. Quick question, go ahead. Alec, you have a question? Go ahead, please.
Eventually.
So you know how for StatCrunch, it's the online calculator. Yeah, I'm aware of that, yeah. Can we use that for the final? Yeah, I don't care. Use whatever you like. Yeah, use whatever you like, right? As long as it's an online calculator is total fine. You can use websites that have calculators. You can use your own calculator. You can have a Crunch it, whatever. All these different programs, you're more than welcome to use any one of them you want. Thanksgiving was very nice. I went out to a friend's house. My dad stayed here, and then I came back and I had a second dinner with him. So I ate possibly a little more than I should have. Turkey, it's the standard. It's a standard, Thanksgiving food, and a lot of other stuff that are not necessarily the standard Thanksgiving food. Because I figured, you're going to cheat on your diet, you might as well go all out. So I went all out. Anyways, review time. Stop asking me about what I ate. So the mean. The very first one is the mean. On page 40, you know, of course, how to calculate the mean. I did have a little bit of soda. I wasn't perfect. I didn't have any orange creamsicles, but I did have a little bit of soda. I'm sorry. I was like not going to, but then I did, and it was horrible with me. I know. I'm sorry. I was like telling myself, like, okay, eat what you want, just don't have any soda. And then I had some soda, so that wasn't great. But what can you do? I'm already lower than I was before Thanksgiving, so I'm back on track. Anyways, come on, guys, math. Don't get me monologuing here. So on page 46, we have the mean. You should know how to calculate the mean. We also have on page 46 the notion of a resistant measure. Very important concept, a resistant measure. A measure of anything, whether it's a measure of center or a measure of spread, is a resistant measure if it's really tough to change it. Okay? If an outlier doesn't really change it, it's resistant to change. It's resistant measure. So the mean is a non-resistant measure, because if I have one big outlier, that's going to affect the mean significantly. On page 47, on the other hand, we have the concept of a median. The median is a resistant measure. The median is very tough to change because you add one outlier, the median will not really move that much. So you should know how to find the mean, and you should know how to find the median. And both for the case of odd and even scenarios, right? You should know how to find the mean, and you should know how to find the median. Okay. On page 49, there is a little blurb on the top of page 49 which talks about the difference between the mean and the median. You should read that one. On top of page 49 are 3 sentences. I'm not just going to read them, but you should certainly read them yourselves. It is an important feature relating the mean and the median together. Next, that's all about measuring center, right? We have the mean and the median as 2 different measures of center. Now, starting on page 49, we want to measure the spread. And the first way that we measure the spread is via quartiles. Okay, this is on page 49, the concept of a quartile. More specifically, on page 50, we have the first quartile, the second quartile, and the third quartile. Anyone give me a name of the second quartile? What's another name for the second quartile? The median, exactly, excellent. The quartiles divide all of your data into 4 equal parts in terms of data points, not in terms of size. The first 25%, the next 25%, the next 25%, the next 25%. First quartile, second quartile, third quartile, fourth quartile. And you should certainly know, because we spent time on this, you should know how to find the quartiles. On page 51, we have the 5-number summary. The 5-number summary are what 5 numbers? What are the 5 numbers in the 5-number summary? Anyone recall? No? They're the minimum,
Q1,
Q1,
The median.
the median,
Q3, and maximum.
3, and the maximum. Okay, so the 5-number summary. And what visual display goes directly along with the 5-number summary?
The box plot thing.
The box plots, right? So the box plot also on page 51 is the box plot. Then on page 53, we have the concept of the IQR. On page 53, we have the concept of the interquartile range. What is the formula for the IQR? What is the interquartile range?
Q3 minus Q1.
Excellent. Q3 minus Q1. Very good. Q3 minus Q1. Okay. Then we had a way of taking the IQR and determining whether or not something is an outlier. Does anyone recall what that procedure was? The way of taking, yes, we take 1.5 times the IQR. This, by the way, is on the top of page 54. We take 1.5 times the IQR. And what do we do with that number 1.5 times the IQR? What is 1.5 times the IQR? What do we do with that information?
We add it or subtract it from the minimum and maximum.
Not from the
We-
minimum and maximum, because nothing's past the minimum or the maximum. We're trying to determine what the outliers are. If we subtract from the minimum or the maximum, what's that going to do for us?
From
So
Q1 and Q3.
From Q1 and Q3. We subtract from Q1, we add to Q3, and then we have these two numbers. Anything past this or past that would be an outlier. Okay, so make sure that you look that up. That's on page 54. We have another method on page 54 for measuring spread, and that is the standard deviation and the variance. And those two are also on page 54, the standard deviation and the variance. You should certainly know how to calculate those, the formulas. And you should also know on page 56, when do you use which? When do you use the 5-number summary approach, which includes the IQR, the quartiles, the median, etc.? And when do you use the one that's about the standard deviation and the mean?
Don't you
So-
use the IQR when you're given the median and then the standard deviation when it's the mean?
So yes, the standard deviation always goes with the mean, and the IQR always goes with the median. There's no question about that. The question is, how do I know which pair to use? Do I want to use the median IQR pair, or do I want to use the mean and the standard deviation pair? Which is the correct pair to use?
When you have like small amount of outliers, you use
Say again?
when you don't have any like outliers, or when it's like not that skewed to the left or right, when it's more, what's it called, when it's more
Symmetric.
symmetric, you use IQR.
Oh, we had it backwards. You use the mean and the standard deviation if it's symmetric, and you use the median and the IQR if it's not symmetric or if there are outliers. Okay, so you should certainly know that. That's on page 56. Okay, and that's it for chapter 2. So, okay, is there any question, not on how to do problems, which there's always going to be questions on those, but is there any question on what you need to know from chapter 2?
Professor,
Yes,
for the final, how long is it going to be?
it's a 2-hour final.
Do you know how many questions it is? Is it like one from each chapter?
Not exactly. I believe it's a 25 multiple choice, and then
So we have to show our work on a separate piece of paper and send it to you, correct?
Where are you getting that from? Did I tell you that?
You did that last class, yeah.
I tell you that? I don't think I said that. I think on Canvas, there's going to be multiple choice questions, and then you're going to have free response questions, and you got to show your free response work. I don't know if you have to show.
You were telling us about your chemistry class.
Yeah. Oh, my chemistry class. That's how I did it with that. This is not.
Yeah, but then you said we might do it like that. That's why I was just asking.
We haven't done that in previous semesters, so I don't think we'll do it now. I mean, the only thing I can think of is if you want partial credit for work, like if you get something wrong, and you want to have you want to have credit, you're like, okay, yeah, I got it wrong, but I believe I did part of it correctly type thing, then yeah, certainly send in your work, maybe something can be done. But either way, it won't be available until the second it's supposed to start, which is 10:15. 10:15 a.m. and then 12:15 a.m. It's yeah. I mean, that's just. Anyways, let's focus on this right now. We can always answer those questions later. Okay, so let's move on. So are there any questions on the first two chapters? Again, let's not worry about that right now. Let's focus on getting the review done. We can answer questions at the end. Are there any questions in the first two? Okay, so let's move to chapter 3 then. Chapter 3 starts with, this is the normal. This is the section on the normal curve, okay? So the normal distribution. So we're starting on page 73 with the concept of a normal distribution. Okay, the concept of a normal distribution, okay? Sorry, let me rephrase that. We'll get to normal in a minute. The concept of a density curve, for which a normal distribution is just one part, a density curve, okay? A density curve is a graph that is used to model a given situation, the normal being one particular model. That's the bell curve model. There are significantly other models that we might use. For example, the chi-squared model is not normal. The t distribution looks normal. This is on page 73. The t distribution looks normal, but it's not exactly normal. But a density curve, you should certainly understand the two conditions for a density curve. One, the area underneath it has to be 100%. It has to be 1. And it can never be negative because the density curve is measuring probabilities, and probabilities can't be negative, right? So if you add it all up, you have to get 100%. So on page 76 now. So again, on page 73, which is the concept of a density curve. And now we're on page 76. On page 76, we talk about the mean and median of a density curve. Where is the mean and median located? You see, in the previous chapter, when we did median and mean, we had data points. So yeah, we could put the data points in order and pick the one in the middle. We can add them up and divide by how many we have. We had a mathematical way of finding the mean and the median. But now we have a curve. And the question is, where is the mean and median on the curve? So on the top of page 76, we talk about the mean and median on the curve. The median is the point of the curve where 50 cents below and 50 cents is above, 50% is above. The mean is more is the balance points. If I were to build this curve and I had it like on a wooden board, so I had this curve on a wooden board, where can I put my finger so that it would be perfectly in balance and it wouldn't tip one way or the other? Thank you. That, and by the way, my class is on. Hi. Okay, good talk. That is where the mean would be located. Also on 76, we have the concept of we give symbols for the mean. Oh, it's just the pasta. It's just my usual nightly pasta, which is horrible. But we have symbols for the mean and the median. Anyone remember what Greek symbols we use for the mean and for the median? They are the Greek symbols mu and sigma, which can be found on page 76. And also on page 76, we start talking about the normal distribution. The normal distribution is the bell curve distribution. This is the bell curve. This is the big one. This is the one that we've used for pretty much the entire rest of the course. Okay, if you don't know the normal, I don't know how you would have known pretty much everything that we've done subsequently. The normal is that important. Normal is symmetric. The mean and the median are right in the center. We had on page 78, the 68, 95, 99 point mean and mu and median is sigma, yes. We had on page 78, we had the 68, 95, 99.7 rule. The 68, 95, 99.7 rule. Could someone remind me what that rule was, please?
Within the first standard deviation, 68% falls in it.
Wonderful.
Within 2 standard deviations, 95% of the data falls in it. And then within 3 deviations, it's 99.7.
Amazing. That's exactly it. That's on page 78. Then on page 81, we talk about what is called the standard normal distribution. Okay, the standard normal distribution. And we get there by taking z-scores. This is still on page 81. What is the formula for the z-score? Anyone recall that one? How do I get from my data to the z-score? Well, it's on page 81. If you don't know it, that's not good. This is one of the more important ones. So on page 81, the z-score. What is the mean? No, you don't look at a table. Z-score is immediate. A z-score, we have a formula for the z-score. Okay, you get the z-score from your data. And also on page 81, you should certainly know what the z-score physically is telling you. Not just how to calculate it, but what it's telling you. On page 82, we talk about the standard normal distribution, which has a mean of what's and x minus mean over standard deviation, x minus mu over sigma, exactly. On page 82, we talk about the standard normal distribution and what is the mean and sigma for standard normal distribution. The mean is 0 and the standard deviation is 1. Excellent. Mean is 0 and standard deviation is 1. Very good. Very, very good. And then on page I guess this is more pages. On pages 82 through 85, or better yet, through 86, is a way of calculating probabilities from z-scores and from raw data. That whole stretch. There's no like one little formula part. It's just a whole skew of like 4 pages where they go over how to do it. I should certainly look that over and make sure you know how to do it. On page 87 to page 88, they go backwards. From the probability, they calculate your data or your z-score. Sydney, I'm not sure what you're asking me to repeat. I'm not sure which part I said. So what you said, can you repeat that? But I don't know what that is referring to.
It was right before what you said just now.
So if I say, for example, here's a distribution that's normal, what's the probability of being between 17 and 84? You should be able to calculate that based upon knowing the mean and the standard deviation. And if I say the probability being less than this number is 6.2%, what number is it? You should know how to calculate that. That's on pages 87 through 88. Okay, that's using the normal CDF or the inverse normal on your calculator. We've certainly done problems like that as well. And that takes us to the end of chapter 3. So now we are moving on to chapter 4, okay? If you're not sure how to do something, of course, you know what to study. So my next question is not about knowing how to do it. My next question is, does everyone all caught up on the list of things that I'm asking you to know for the final? Is there anyone that missed something? Again, this will be on video, so you can obviously look at it later. I just want to make sure that everyone is on the same page in terms of what you have to know and the pages that they're on. Okay, so next, chapter 4. Chapter 4 can you repeat the last one you just said, the page numbers? That was 87 to 88. Pages 87 to 88. Okay, next. Chapter 4 is on scatter plots and correlation. So 98, top of page 98, the difference between a response variable and an explanatory variable. You should understand the difference between a response variable and an explanatory variable. On page 99 is the concept of a scatter plot. A scatter plot continues to page 100. So in fact, I think 100 is probably the better page to look at. On page 101, when looking at scatter plots, we look for a number of things. We look for 4 things in particular. What are the 4 things that we look for in a scatter plot? What are the 4 things that we look for in a scatter plot?
Direction, form, strength, and an outlier.
Are you just reading the page or are you doing it from memory?
I'm actually looking at my notes that I took in the beginning of the class.
Okay, so your notes are good then. Okay, direction, form, strength, and outliers. Direction. Well, first, form. Is it linear? Is it nonlinear? Next, direction. Is it increasing? Is it positive? Or is it decreasing? Is it negative? Strength. Strong, moderate, weak, non-existent. And finally, outliers. Are there any things that just deviate from the overall pattern? These are all things that are mentioned on page 101. Something else mentioned on page 101 is the concept of clusters. You might have a bunch of dots that are clustered in different areas. So some dots here, some dots here, some dots here. And perhaps there's some underlying significance for what those clusters are referring to. In terms of the direction on page 102, it distinguishes between positive association and negative association. On page 103, about linear versus nonlinear. On page 105, it talks about adding a categorical variable to a scatter plot using different colors or different symbols. We did something like that. On page 106 is a formula to calculate the correlation that we never used. I don't think we ever used this formula to actually calculate the correlation. Strength is how close it is to a line, right? You know, if it's perfectly linear, it's I mean that's obviously a line. But if it's just near there, it's very strong. And the further away until you get to the point where you're like, I don't even see a line, that's non-existent or weak, right? So there's a scale from non-existent to perfect. But on page 106 is the formula for the correlation. You should probably have it written down just to have it. Yeah, you don't need, we don't use a formula, but listen, you're making a cheat sheet for the test, write it down. But I don't really anticipate a situation where you would need it, but it's there to have. On page 107 to 108, there are some facts about correlation, things that you should know about correlation. The first one on the bottom of page 107 is that if you switch the explanatory and the response variable, who cares? Correlation just does not tell you about causation. It just tells you about association. How connected are those? They're connected whether they're X and Y or Y and X. They're still the same connection. It does not depend upon units. This is on top of page 108. It does not depend upon units. If you change it from inches to centimeters to feet to miles, you'll get the same correlation. Positive correlation gives you a positive association, and negative correlation gives you a negative association. And the correlation coefficient is always between -1 and 1. So those are the 4 facts about correlation as listed on page 108. And that takes us to the end of chapter 4. R, the correlation coefficients, is always between -1 and 1. The correlation coefficients is always between -1 and 1. Okay, so that takes us to the end of chapter 4. Are there any questions on what you need to know from chapter 4? Not how do I use them and what type of examples am I going to have and this and that, but are there any questions simply on what you need to know? If not, let's move on now to chapter 5. Chapter 5 is on regression, which is the other side of correlation, regression. Regression is fitting a best fit line. That is defined on page 121. Regression is making a best fit line. On page 125, they define what the least squares regression line is. Okay, out of all possible lines, why is that the best fit line? Because it minimizes the sum of the squares of the residuals, right? This is what the least squares regression line does. That's on page 125. What's the formula for it? That's on page 126. Much like the correlation, your calculator can do it all for you if you have your data. However, I do know that on previous tests, we certainly have needed the equations on page 126 for calculating the best fit line once you have your data points, like you need to know your X bar, your Y bar, your S of X, your S of Y, and the correlation coefficient. All those equations are on top of page 126. On pages 128 to 129, you have some facts about the best fit lines. For one thing, even though the correlation doesn't matter the order, the best fit line does. So explanatory and response, that does matter. That's not something that you can just ignore. Okay. Number two says the slope of the best fit line and the correlation of the best fit line always have the same sign. The slope of the best fit line and the correlation of the best fit line always have the same sign. Number 3 says the least squares regression line always passes through the point X bar, Y bar. So when I look at my data, I'm going to have all these points, and they're going to have X values and they're going to have Y values. If I average the X values and I average the Y values, I will get a point, which is X bar, Y bar. The best fit line always passes through that point. So it's a good point to draw first if you were doing this by hand, because then you can kind of look at all different lines that go through it and kind of adjust it to decide which of them is the best fit line, because you know that point's going to be on the line. Number 4, and we talked about this, the square of R squared, is the percentage of the variation in Y explains by the best fit line. We talked about that. That's on page 129. I would just write it out, because if you ask a question on the test, you can just kind of copy it. On page 131, they define what a residual is. A residual is observed minus predicted. Very similar, by the way, to our chi-squared. If you recall from last week, the chi-squared values was the sum of the observed minus expected over squared over expected. That observed minus expected, that's what a residual is. In this case, it's observed minus predicted, but it's very similar. So on page 131, know what a residual is. On page 133, you should know what a residual plot is. I'll give you guys a couple seconds just in case people are falling behind. On page 135, an influential observation, R squared. So again, Sydney, the best way is just to read it, because I can say it again, but it still doesn't really sink in. It's on page 129. Okay, it's the fraction of the variation in the values of y explained by the least squares line. It's tough to wrap your head around. It's a tough one, but you should certainly look that over, and hopefully as we go later in the chapter or later in the book, it'll make sense. I don't know the ebook. I think the ebook is the same as this book. Is that not the case? Is the ebook not the same as this one? Oh, I know. I can tell you what chapter we're in for sure, but in terms of the page number, it's page 129 in my book. So I don't know what page it is in your book. I hope it's the same, but I don't know. 135, an influential observation. Do we all know what an influential observation is? Well, make sure you look it up. An influential observation is one that has a significant effect on the best fit line. If I have 2 points right here, and that's the only 2 points I have is, right? If I have dots, dots, then that's my best fit line. But if I include that, now that's my best fit line. That one observation drastically affected my best fit line. It is an influential observation. So that's on page 135. On page 138, we have the concept of extrapolation, which is something that you do not want to do. The concept of extrapolation, don't do extrapolation. We always like to ask questions in the test about, okay, here's your data. What does it say about this guy over here? And you're like, oh, can't do it. I'm extrapolating. That's outside the data points. Can't do it. That's what extrapolation is. And then we have the idea of a lurking variable. A lurking variable is a variable that's lurking behind the scenes. That's really the one that's influencing your data. It's not something that you're considering, but it's really there. That's on page 138. On page 140, we have the very important concept that association does not imply causation. All that your least squares regression line can do is talk about the connection between two variables and not whether one has a direct impact on the other. Perhaps something is lurking behind the scenes. And that takes us to the end of chapter 5. Any questions so far? Any questions so far? If you had a test right now on those first 5 chapters, who are things to be like, I think I do pretty good because I kind of know this stuff. I don't know. We'll see what we get to. We'll see what we get to. It's a good question. We'll keep going for a little bit at least. A solid 70. A solid 70. I've never really heard the word solid and 70 together in this context, but a solid 70. Okay. The least square regression line, it's the best fit line. The best fit line is the least square regression line. The whole chapter is devoted to the least square regression line, how to find it, how to interpret it, what it means. It's all in chapter 5. Okay. Did you get all those pages, Sydney? All those pages that I mentioned? Yes, no, maybe so. Yes. Yes, no, maybe so. Page 135, I think so, yeah. Page 135. All right, so now we're starting on page chapter 6. So this is now on page 154. Even though we did chapter 6 kind of really late in the course, we're just going to do it now because we're just going in order anyways. So even though we did chapter late in the course, we're going to do it now. Okay. In chapter 6, we have on page 153, we have the concept of a two-way table. Okay, the concept of a two-way table. And this we did really recently, right? This was the idea of two categorical variables. And, you know, you had the first categorical variable for the columns and the second one for the rows. And we had the totals on the side and the margins. And those are called, if you look on page 154, those are called the marginal distributions. That's on page 154 is the marginal distributions. Okay, so you should certainly know those. And then on page 156, we have conditional distributions. And when we did this last week, or 2 weeks ago, I don't even remember what it was, we got through chapter 6 pretty quick. I mean, I think as a class as a whole, it really just was very intuitive. So much so that I don't even think there's any homework on chapter 6. We just put it all on chapter 25, which is why we're doing it. Chapter 6 by itself is really, really, really just straightforward. What's not so straightforward was Simpson's paradox on page 160. And we did Simpson's, excuse me, we did Simpson's paradox on page 160. And just an FYI, anytime I had seen Simpson's paradox actually used in practice, it was always with a multiple choice question. What is the thing that's called? And then basically what Simpson's paradox is. So it's, you don't actually use it. You just recognize it when you see it. And that takes us to the end of chapter 6. Chapter 7 has no useful information in it. Chapter 7 is a review chapter with nothing special in it. So at this point, we have reviewed up into page 191, which is roughly 1/3 of the course. But I want to go a little bit further just because it's only 7:25. And what I would really like to do is get to the point before the major topics of confidence intervals and hypothesis testing come up. Is anyone feeling overwhelmed with how much information I've given you so far, honestly? Well, it's all on video. Now, we talked about Simpson's pair. Remember we did the example of accidents and whether or not we want helicopters to take them to the hospital or whether they go by cars? Really? But this is the only course that I would cover Simpson's paradox. Did we not do it? We didn't cover it? But two-way tables we did, right? Two-way tables we did, right? Chapter 6.
Wait, two-way tables. That's the chi-square thing, right?
Yeah, we did the chi-square thing, right?
Yeah, we did that chi-square.
But we didn't do Simpson's paradox. Okay, so you know what? Let's do it now. Let's do it now.
So the two-way table is basically the chi-square?
Well, the two-way table leads into the chi-square. The two-way table is what you basically need to do a chi-square test. But we certainly talked about things like, you know, well, remember the one that we did on page 154 about college women no college, women college, men no college, men college. And then we had job outside home and whether they want to do this or whether they want to do that. Does that ring a bell?
The only thing that I think we did right after we finished hypothesis and confidence interval, I think we jumped right into chapter 24, which was chi-squared, and then we did the most likely like living in parents' home or another home or
Yeah. That one.
So I don't think we covered the two-way table, marginal distribution,
Okay.
condition, and Simpson paradox. So I don't think we did chapter 6 at all. A little bit, because I think we skipped to chapter 24 right away after the test 3. I can be wrong.
No,
Go ahead.
hold on. I'm checking something here. 1 second. 1 second. I thought we did it. Oh well. Okay. All right. This semester's killed me. I'm all over the place. I am usually much more organized, but I'm sorry. So, okay. So then what we're going to do now. Okay. So then let's talk. Okay. So let's. Okay. Does everyone have the book? Does everyone have? I think it's called. Oh, yeah. It's called All of Us. I know.
Don't we have it if we bought the homework service thing?
The homework service thing. What's the
The Launchpad system?
You should have it. You should have like an ebook or something like that if you don't have the actual one.
It's the same one though, right? It's not a different one.
No, it's the same one.
Okay, perfect.
Okay, so everyone has access to that right now? No, it's chapter 6. It's chapter 6, which is, there's no homework on chapter 6 because it's so quick. And I really thought I did it before we went into the chi-square stuff.
Wait,
So let's
just
do it now because it's really straightforward. Let's do it now. So does everyone have access right now to the book that they can look at so that when I tell you to turn to a certain page and look at a certain problem, we can all do that? Okay, so everyone please turn to chapter 6 on two-way tables. Let's all do that please right now. Everyone turn to chapter 6 on two-way tables. And in particular, I would like you to look at the one on page 154. Table 6.1, the first table of the chapter. And what this does is it gives a relationship between two categorical variables. What is the row categorical variable? How is it labeled, the row categorical variable? I'm going kind of slowly to make sure that we're all on the same page here. What is the row categorical variable?
is this page 154?
This is on page 154. What is the row categorical variable?
Is it the total, the distribution of sex and education level?
Yeah, sex and education. And what is the column
And then
variable? Huh?
Is it preferred lifestyle?
Preferred lifestyle. So these are two categorical variables, not quantitative variables, right? These are both categorical variables because they're not things that are measured by numbers, right? Women educate, women no college, women college, men no college, men college. Those are not quantitative, those are categorical. I prefer to have a job outside the home. I prefer to have a job, stay at home and take care for the house and family, or no preference. Those are very categorical. In this study, how many people were talked to? How many people were surveyed in this study? What's the total amount based upon this table of the people that were surveyed in this study?
1,012.
1,012. You can see that in the bottom right corner, correct? 1,012. We all agree? Of those excuse me, sorry. Of those 1,012, how many were women who had a college education that preferred to stay home? How many of those 1,012 were women with a college education who preferred to stay home?
29.9%.
No, not percents, not percents. It's how many?
303.
115.
115 is what I see. I see 115, right? It's the second row, women no college row, and the second column, stay home and care for family column. I count 115. Do you not? Yes, no, maybe so?
Yeah.
Okay. How many were men with no college who preferred to have a job outside the home? How many were men with no college education who preferred to have a job outside the home?
When no college is 92.
92, right? All you do is you read it off the charts, right? So far, pretty straightforward, at least in concept, correct? Yes, no, maybe so? Yes, no, maybe so, guys? Okay.
Yes.
Now, those are all situations where you are looking at the overall numbers. Okay, you're looking at the overall numbers. Okay, what if instead I asked the following question? Of the women with no college, what percent of them would rather have a job outside the home? Of the women with no college, what percent of them would rather have a job outside the home?
Is it 41.5%?
Where are you getting that from?
The woman no college job outside of home, 41.5%.
I'm not sure what you're looking at because I don't see percentages on my chart here on page 154. Do you all see percentages in your chart?
Table 6.1.
Table 6.1 in my book does not list any percentages. Table 6.1 in my book just lists numbers. It says there's 173 in that cell. Do you not?
Oh, I'm on the wrong page. I'm sorry.
Okay, so again, how many women with college education would prefer to have a job outside the home?
Outside the home. Okay.
How many women with college education would prefer to have a job outside the home?
Would it be 17.1?
No, not percent, just how many? How many women, according to this table, how many women with a college education would prefer to have a job outside the home?
173.
173. So what percent of women have both a college education and would prefer to have a job outside the home? How would I calculate that? The percent of women who have a college education but prefer to have a job outside the home. What would be the math? Don't give me the final answer because I'm not looking at my calculator. What would be the math for that one?
Wouldn't it be 173 divided by the total?
Yes, it would be 173 divided by 1,012. And whatever number you get, done. But now I'm asking a different question. Of the women with no college education, what percent would prefer to have a job outside the home? This is a different question because I am conditioning it upon it being women with college education. Very, so close. That's no college. You're in the wrong row. I'm talking about women with of the women with a college education. It will be 173 divided by 303. I focus my attention only on that row because I only care about the people in that row. Of the women with college education, of those 303, how many want to have a job outside the home? 173 over 303 would be the percentage. We call that a conditional distribution because I am conditioning it upon one of the totals in either the row or the column. Also called a marginal distribution, because I'm using the marginal values. Does that make sense? Technically, it's conditional. Marginal is a little different, but technically, that is what a conditional is. All you have to do is read the question carefully. If I said, of the people who want to have a job outside the home, what percent are women with college education? What would the answer to that be? Again, of the people who have a job outside the home, what percent are women with a college education? What would the answer to that one be? As a fraction, because I'm not looking at my calculator. Of the people who prefer to have a job outside the home, what percent are women with a college education? No. So you're not considering the conditional. It's 173 over 645. Of the people who prefer to have a job outside the home, we only care about those people. Nothing else in the table matters. So I'm not looking at all the table. I'm only focusing on the one column job outside of home. Of those people, of those 645. Well, you don't have to add the denominators. You just, the bottom is 645. They already gave you the answer to that. I already know how many people fall in that category. Right? The total's in the bottom, 645. That's how many people have jobs outside the home. Of those 645, 173 are women with college education. So you notice that we get a different value. This is what chapter 6 is. It's the difference between a marginal distribution and a conditional distribution. Okay. And that's it. That's basically all there is in chapter 6 with two-way tables, which is kind of like why I just assumed that we did it. Simpson's paradox, on the other hand, you'll find on page 160. So let's please look on page 160 to Simpson's paradox. So example 6 point. Okay, so what's the difference? Good question. Let's look on page 156. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. A marginal distribution would be something along the lines of this. Let's look back at the table. What percent of the people questioned are women with a college education? What percent of the people questioned are women with a college education? What will be the fraction for that? What percent of the people questioned are women with a college education? What will be the answer to that? Based upon the table on page 154. Again, what percent of the people questioned are women with a college education? No, I made no mention, Mariah, of job outside home. So 173 is limiting my attention to the column job outside home. Right? I just said what percent are women with a college education? That's not a percent, 303%. No, give me the fraction because I'm not using my calculator. Yes, 303 over 1,012, which I think would be about 30%. So that's probably where you got it from. Okay, notice to answer that question, I didn't actually look at any of the data in my table. I only looked at the margin. I didn't need anything else. Does that make sense? So a marginal distribution is one that only requires information from the margin. So sex and education, if I just look at that, that's a marginal distribution because I'm only looking at the margin on the right. Preferred lifestyle, that's a marginal distribution because I'm only looking at the numbers on the bottom. Those are both marginal. A conditional distribution is when I condition it upon one of the values in the margins. Given that I'm only talking about men who with no college education, I am conditioning upon that, then what's the value of X, Y, or Z, whatever. Okay, that is the difference between marginal and conditional. Does that make sense?
So for marginal distribution, you're only looking at the education.
Well, I'm only looking at the margins. Nothing else matters in the problem. All that matters is the margins.
So for this example, the margins would be the sex and education.
Well, it would be the numbers in the bottom or the numbers in the right.
And then it turns into conditional distribution when you combine that with the preference.
No, not when I combine it. When I condition upon something. I say, of the people in this category, of the people in this row or this column, what percent also have the other variable? That would be a conditional distribution versus a marginal distribution. So for example, sex and education by itself is marginal. Preferred lifestyle by itself is marginal because all I care about are the numbers in the margins. But if I say something along the lines of, what is the distribution for men with college education? Now I have the three numbers in that row, but I only care about the three numbers in that row because I'm conditioning it upon that row. Nothing else matters but that row. Everything else I can completely ignore from the problem. It's like it's not even there. I would literally cover it with my hand or my finger or something to indicate that it's not there. Does that make sense? Does that make sense, guys? I'm limiting it to either one row or to one column. Yes, I'd be limiting it to either one row or one column. That's correct. Now on page 160, we have Simpson's paradox. Okay, so let's just take a look at Simpson's paradox. Example 6.4, do medical helicopters save lives? It says accident victims are sometimes taken by helicopter from the accident scene to a hospital. Helicopters save time. Do they also save lives? So let's compare the percents of accident victims who die with a helicopter and with the usual transport by ambulance, by road. So let's look at that first table. What percent of helicopter victims survive? This is conditional because I'm conditioning it upon a helicopter. What percent of the helicopter victims survive? 136 out of 200, that's 68%. So 68% of helicopter victims survive. What percent of road victims survive? 840 out of 1,100. What is that number equal to, by the way? 840 out of 1,100. Can anyone do that for me, please? What's 840 out of 1,100? What does that equal to? 840 out of 1,100. What's the math?
About 76%.
About 76%. And what was the 136 out of 200 again? What was that equal to? 68%. So it seems on the surface that you have a better chance of survival if you go by road than if you go by helicopter. So why would anyone ever want to go by helicopter? It seems if you want to survive, you're more likely to do it by road. Does that seem reasonable?
No, because because you're associating causation with it. I mean, sorry, you're associating it. Blah, blah, blah. Okay, let me start again.
Okay.
Those don't depend on the severity of the crash. Those are just the form of transportation.
Okay, so there you go. There's a lurking variable behind the scenes, which is people who go by helicopter tend to be worse off to begin with. And therefore, they're probably naturally going to have a less likely chance of surviving than people who go by road. So you're missing some information, which is perfectly reasonable and I think very intuitive. But now let's look at the other two tables, the ones on the bottom. Now we're going to divide up the information into serious accidents versus non-serious accidents. So let's look at the serious accidents. Of the serious accidents, are you more likely to survive by helicopter or are you more likely to survive by road? Look at the data on the table on the left. For the serious accidents, are you more likely to die, to survive by ambulance? Try that again. Are you more likely to survive by helicopter or by road? Helicopter, correct? Helicopter is 52% and road is 40%. So if for serious accidents, go by helicopter. What about the less serious accidents? Which one are you more likely to survive by? Look at the data for the less serious accidents. Which of them are you more likely to survive by? Helicopter or road? Not according to the data, you're just guessing. Because if you look at the math, you don't get that. Don't guess, don't guess. Use brains, use thought processes. If you look at the less serious accidents, what percent survive by helicopter and what percent survive by road? Give me the numbers, don't just say something. What percent survive by helicopter and what percent survive by road? 84 over 100, 84 over 100, which is what percent is that? What's 84 over 100? 84%. And what is it by road? 80%. So it looks like for serious accidents, you're more likely to survive by helicopter. For less serious accidents, you're more likely to survive by helicopter. But if you lump it together, you're more likely to survive by road. That's the data. Serious accidents, go by helicopter. Non-serious accidents, go by helicopter. But just in general, go by road. That is Simpson's paradox. On the bottom of page 160. An association or comparison that holds for all of several groups can reverse direction when the data are combined to form a single group. This reversal is called Simpson's paradox. Do you see how that applied to this situation? When we look at just serious, go by helicopter. When we look at just non-serious, go by helicopter. When we lump them all together, go by road. In reversed direction. That is Simpson's paradox. And the reason why Simpson's paradox exists is because of the nature of the lurking variable and the size of the samples. We're not going to do any questions about all of that together. The only types of questions that you'll be asked on a test, on a final, are Simpson's paradox is, and then it's just a matter of picking a multiple choice that says this. Okay, you're not going to actually be asked any questions mathematically on Simpson's paradox. So don't worry about that. It's purely understanding the idea. So that takes us to the end of chapter 7, which is essentially the first exam plus a little bit at the end. Okay. So I am going to stop